All right, now let's move on to what we're going to do with the results of our regressions. Let's assume that we've done things in the best way possible. We've taken care of all the issues that exist as best we know how, and now we want to save the results. So there are a number of different ways you could do this. Maybe before you directly save the results, you may first want to look at them. So we know, okay, we've got, for example, these here, but maybe we want to, in the same way that we used to use, or we used return list after summarize, we might want to try doing eReturn list. eReturn list you would use, for example, after running some regression and some other things. You're going to get a number of scalars in temporary memory. And there are ways that you can capture these in a matrix that you may want to use later. So you can use matrix or just mat. You can define some new matrix that is going to be in Stata's memory until you close it or clear them out. You can say this, because E and then B in parentheses right here, this is going to be a vector of your estimated coefficients. B for the betas. So if we do that, then we can matrix list or just mat list beta hats if we want to look at that. And then if we run some new regression, maybe on some new outcome variable or something else, we would have all of this wiped out, or it would be changed, but we would still have this in memory. Now, this is not a new variable. It is all matrices and vectors that you store in Stata are going to be sort of stored separately unless you tell Stata that you want to turn them into variables or into a variable, a bunch of values for it. But you can work with them in ways that may be useful to you. Maybe you don't want to have a 1 by 5 matrix. Maybe you want to have a 5 by 1 matrix. I'm not going to go over a lot of the stuff you can do with matrices, but just to give you an example of how you can change things around. Maybe you want to do mat beta hats equals beta hats, and then this little prime here. And then if you mat list beta hats, you can see it's now become a 5 by 1. So you can put these into a table if you want. I can show you how to do that on your own. I'll mention one or two resources that I think are useful. But you may want to actually use some of Stata's built-in capacity to store your estimates and to create tables. So let's go back to the simple regression of price on miles per gallon. Let's say down here, let's do that, sorry. Call this storing estimates. So let's quietly regress price on miles per gallon. That way we don't have to look at the output. Let's say we want to store those estimates. So estimates store, and let's say that's naive. We're going to call these naive estimates. Let's then quietly regress price on miles per gallon, weight, foreign, and rep 78. Let's use robust standard errors. Let's estimate store, and let's call those robust estimates. We can run that. Let's quietly regress price on miles per gallon, weight, foreign, rep 78. And let's cluster our standard errors on foreign. And estimates, store, you can say cluster. So we'll call those estimates. And then finally, maybe we want to IV regress to SLS, price, weight, length, rep 78, miles per gallon equals foreign, VC, cluster, foreign, estimates, store, let's say instrument, and let's run that. No, let's show an E. So maybe we want to call the estimates now. So maybe you just want to see what you have as estimates. You can estimates dir. And you see you've got the things that we just saved, and you can click on them if you want and bring those up. Go back, cluster. Or maybe you don't want to click on things, maybe you just want to bring up the clustered estimates. You can just estimates, restore, and then cluster. And you can click on that, or you can just call this, and then return list. So you might say, okay, great, I've stored my estimates like this. You know, that's useful for me. I can go back and look at them, but I really want them in a table. So maybe let's call the section put stored estimates in tables. So type estimates table, naive, robust, cluster, not cluster, cluster, and instrument. And now we've created a table with the columns being titled as we called the estimates, and all the variables of interest listed here, all the ones that are included at all. Obviously naive only included miles per gallon, robust and cluster did not include length, but the instrument did include length but not foreign. And now we've got those in a table. Maybe we say that table isn't great. Maybe we can improve that table. Let's use these options. BSE, and you can again help estimates table if you want to look at the options. BSE. Let's see what that does relative to what we just got. And what do you think the difference is between these two now? Between this and where we use BSE. The standard errors have been put underneath the beta hats in the table. maybe instead of that, we actually want, let's use this option star. What do you guys think that will do? Well, it will tell us whether or not our estimates were significant at the 5%, the 1%, or a more precise level.
Using outrigger?
You can use outreg 2, yeah.
What's the best to use to do that?
I actually create my own tables. I store my estimates in a matrix, and then I use format table, FRMT table, and that way you can change everything. It definitely takes more work, but I think it's just much more versatile. It is worth keeping in mind, rather than caring about significance at the 5%, the 1%, or the 1/10 of 1% level, a lot of papers will care about it at the 10%, the 5%, and the 1% level. So you want to consider what levels of significance matter to you. Maybe you want to do even more with this estimates table option or command. So that's percent 5.2f. So we're changing the formats of those. And stats n r2a. It's just going to be the number of observations that we had, n, and the adjusted r squared. Let's see how that looks. And that is a nicer table than this because we've got underneath things that some people care about. As I said, I don't use the estimates table command myself, so I can't recall if we can use star on top of this. Yeah, it can't be. So you got to pick one if you're using estimates table, which seems a little problematic. Why would you have to pick? There may be other ways to do that with estimates table. I'm not sure. Like I said, it's not a command that I use. But if you want to use it, I'm sure you'll become more proficient with it than I am. For more advanced, and I would say better, but maybe that's just my opinion, tables, C, est out, est tab, outreg 2, or format table. Now maybe you want to use one of these. Well, first you have to install them. And some of them can just be installed by doing something like ssc install outreg 2. And Stata will check to see if it's installed, and if not, it will install it. It will install it to some subdirectory of your adu folder. And then you'll be able to use it. So if we had typed help outreg 2 before we installed it, then we wouldn't have gotten anything. But now we can type help outreg 2, and we'll have a whole breakdown of how we can use, for example, outreg 2. I like to use format table myself. I always forget. You can't ssc install format table for some reason. I'll show you SSC install format table. It doesn't like it. So if you search for format table, you can see that it seems to be contained within this right here. So if you click on that, then you can click here to install. You guys see how I did that? I typed help format table, and it said it's not installed, but you can click on this. So I clicked on it, then I clicked on SG97_5, and then you can click here to install. And it's going to look and see if it's installed. And it tells me all files already exist and are up to date, but for you guys, it would be the first time. So it'll install it. And I mean, it's entirely up to you, but like I said, like you have more versatility with these commands, so your tables will look nicer. For a first pass at something, maybe you don't care about it looking particularly nice, or maybe you do. Maybe you're like, no, I'm proud of these estimates and I want them to look nice in some table that I show my advisor. Are there any questions on that stuff? Storing estimates or using estimates table? Cool. All right. Moving on. We have an hour left in the course. Advanced regression. For example, fixed effects, interactions, e.g. So let's load the data again. And let's sys use the auto data. And then let's tab rep78 gen, let's say gen FE rep78. And remember what this should do? It should create a new dummy variable for each of the, we can even rep78 underscore here. It should create a new dummy variable for each of the values of rep78. And we look down here and it has FE rep78 underscore 1, FE underscore rep78 2, all the way through to 5. Now let's create a local of controls. So local controls foreign weight length and turn. Turn we haven't used yet. I believe it's the turn radius. Like how sharply can a car turn. So let's make a little note here using a different way of making notes. Again, you can make them however you like. I dot notation. Will treat rep78 equals to 1 as the base case. Regress. So let's reg price on MPG controls and I.rep78. Of course, we have to run the local to call this. Notice how this is different from what we were doing earlier. Apart from throwing turn into there, it's also rather than just treating rep78 as this variable where having a value of 2 is twice as large as having a value of 1, where 3 is 3 times as large a treatment as having the value of 1, which doesn't make any sense because those values of rep 78 aren't supposed to mean something like that. It's not like age where, being 2 years old means you actually are twice as old as being 1 year old. Here, no, rep 78 just shows different categories. So when we do I dot with rep 78, we are actually treating rep 78 as a categorical variable, and we are getting the effects of essentially a dummy of rep 78 for each of these different values. And when we have dummy variables, we have to leave out 1 always, that base case, and so Stata just automatically chooses rep 78 equal to 1. Instead of I dot notation, use individual dummies. So let's again copy and paste this. We may actually here want to define a global. If we're going to do this one at a time, we may want to define a global, but in your do file in general, if you're just going to run it from the top, you can define a local once and then call it a bunch of times, and it will still have that local in memory if you run the whole do file through. So the only reason that I'm including this local again is because we're going time it like a row by row and doing this. So let's reg price mpg controls and then fe rep 78 underscore star. And you don't need to have all of these, you just have like fe or fer, but all of that. And the star is going to, remember, tell Stata that we want everything that has the prefix fe rep 78 star. And remember, we created those dummies. So let's run this. And Stata does the same thing now, except the values on our dummy variables have changed because Stata now chose to omit fe rep 78 underscore 5 rather than 1. So what if we want to use the I dot command, but we want 5, we want rep 78 equal to 5 to be the base case, not equal to 1. So if we want to use I dot but want rep 78 equals to 5 as the base case, let's our local controls again that we're just, remember, we don't need to define it every time if we're just running the do file through once because we're doing this row by row. If you want to have 5 rather than 1 be the base case, then you just I b for base 5 dot rep 78. Then you run that, and it should be the exact same as up here, except it doesn't bother showing that that omitted case. So using the I dot notation, we don't have to create all of these extra variables in our data set. And you can imagine if we have a categorical variable that has, rather than 5, has like 12 or even 20 different cases, like that's throwing a bunch of extra variables in there. It's, just sort of cluttering things up a little bit. You don't need that. So I dot is quite useful.
How's that better than using the star? Oh, I guess you can specify. Never mind.
Yeah, well, and you don't need to have all these variables in the first place to use I dot. you'll need to have rep 78. You don't need to create the dummies themselves. Whereas if you use this, you need to have created each of these.
Oh, okay, so there's no like rep. Okay, I see. I understand.
If we want to time series or panel data, want to use the areg command. So let's include our local of controls again. Now let's areg price miles per gallon, call the controls. Let's absorb. You need to specify something to absorb. Let's absorb rep 78. Now what this is going to do is treat rep 78 as a common unit of interest, and then essentially account for rep 78 fixed effects. So maybe there's some fixed effect to having a repair record of 1, another for having a repair record of 2, etc. And if we run that, then we get this set of estimates right here. Now note, these look similar, but we don't have all of these included here. Let's store those estimates for now. We'll come back to those later. Estimates store 3, call it. Using xtreg. You can use xtset or tsset to do the exact same thing if you are defining some panel. But xtreg and xtset and tsset, you might use them differently if you are not necessarily declaring, say, rep 78 and send some or some panel variable and then some time, for example. So let's xtset rep 78 after, estimate store 3, run both of those. So when we go xtset rep 78, we get told panel variable is rep 78, but then we're told it's unbalanced. Why is it unbalanced? Well, remember, we had tab rep 78. We had 2 observations for rep 78 equal to 1, 8 observations for rep 78 equal to 2, etc., etc., etc. So we don't have a balanced panel here. We don't have the same number of observations for each unit, essentially, if we treat a value of rep 78 as a unit. This declares the data to be panel data and sets rep 78 as the panel variable. Now we have those local controls again. Now we can xtreg price miles per gallon controls. And then we're going to say FE. So look at this compared to the areg command. we have the same dependent variable of interest, the same right-hand side variables with MPG and controls. But instead of absorbing rep 78, here we're going to get the fixed effects from doing this XT-reg regression. Did we not? Oh, sorry, I didn't define the controls there. Okay, so now look here. We have, for example, comparing it to up here, we have done these different commands, but we're actually getting the same estimated coefficients. The standard errors are actually the same here too. This is not always going to be true that we have these identical results from the two different approaches. Just keep that in mind. And if you want sort of a breakdown on which command you want to use for doing some sort of like panel regression, whether you want to use areg or xtreg, there is a post on, I don't know if you Google it, Stata areg versus xtreg. There's a post that explains it really well by some guy. I think he listed his name as Ryan Kessler. Ryan Kessler was a hockey player on the Vancouver Canucks and then on the Los Angeles Kings, so I don't think he actually is writing that, but maybe he is. But yeah, we won't go over the differences between the two. Suffice to say, like, you may want to pick one over the other for certain reasons, and you can get slightly different results.
I have a question.
Yep.
With the local controls, like, even though I'm defining it, it doesn't always give me the output of estimates for those variables. Before I run up the local controls command before I do like one of the commands.
Okay, let's take a look. Oh, so you have to run them at the same time.
Oh, okay.
Otherwise, yeah, Stata doesn't recognize.
Perfect.
Okay, so let's go back here and quickly estimate store. I meant to do this and I just forgot. Estimate store 1 after using this underscore star notation. Estimates store 2, doing that. And then let's just run all of those again. Here, I'll give equivalent results, except for the constants and f-scores. And if you want to see that, you just estimates table 1, 2, 3, 4. Maybe you want to do a few other things with that. For example, keep MPG controls, so we're going to have to define that local controls again. And then say you want to include all of this stuff too. So if we do this, we can see that these different approaches have yielded the exact same thing in this case. Interactions. So let's reload. Reload the sys or the auto data. Sysuse auto.dta clear. Why do we do that? Well, it just gets rid of or drops the those dummies that we had. We could have also just dropped them, but you know, either way, same thing. Now let's generate, or you can quietly generate if you like, light. And let's say that's equal to weight less than 3,000. And what's this going to do? Well, it's going to create a dummy variable that's equal to 1 if weight is less than 3,000. And if you want to see before we work with it, we can see that 35 cars have a weight less than 3,000 and 39 do not. Maybe we're interested in how being light interacts with being foreign as cars. So for example, maybe light cars are priced differently than heavy cars. Maybe light foreign cars are priced differently than light American cars. And just to show you that we can do different things, to make notes, I'll do that. Okay, first way. And quietly, I'm not going to, but you can quietly do it. Gen light foreign equals light, it's minus, equals light times foreign. So you create this new variable that's an interaction of the two. And then you regress price, light, foreign, and light underscore foreign. Oops, not price. So I included light, I included foreign, and light foreign because I don't want light foreign to be picking up the common effect of being foreign. I want to account for all those things individually. So now being foreign has its own effect from being a light foreign. Being light has its own effect different from being a light foreign. And from these estimates, it looks like being a lighter car is associated or correlated with lower prices. Being foreign, once you account for these things, being foreign is associated with higher prices. But being a light foreign car, given that you've accounted for being light and being foreign individually, being a light foreign car is associated with $4,000 lower price. So we can do that, and then we can do the second way. We can just regress price, light, foreign. And we can see that this gives us the same estimates, but we didn't have to create that interacted variable in order to do this. So this yields the same results, but is less work. You also may want to consider that there's a difference between interacting categorical variables and continuous variables. So miles per gallon is it's more continuous, whereas rep 78 is categorical. Yeah, and if you're interacting those things, you just need to use slightly different commands to consider that, like I dot or C dot, and then the hash. So let's save that, and I'll just point out, as an actual do file, this is not optimally organized. It probably would have been better in reality to break, for example, advanced regression off into a new do file, and then sort of had this banner for each subsection of this. Just as a matter of best practices, having one do file for all this sort of stuff is not optimal. That being said, we're not creating this to do a lot.